what?
We don't have it.
Michael, I respect you.
But we're finding delta x.
All
Alright,
You're mad.
Michael, quiet.
Always me.
It is always you. Alright, so remember in all these equations, we can change delta x to delta y and a to g, and some of them I use them interchangeably. So g is always negative 9.8. Remember, anything going up is positive, anything going down is negative. Alright, so let's do number one together. A ball is thrown up with an initial velocity of 9.4 meters per second. What is the highest point the ball reaches? What is the initial velocity?
9.4.
Alright, so initial velocity is 9.4 meters per second. What is the final velocity at the highest point?
0.
0.
0. Remember, at the highest point, the velocity is always 0. Or vertical velocity, anyway. What else do we know?
Well, you know the speed of gravity. You know gravity.
G is negative 9.8. Acceleration due to gravity is negative 9.8 meters per second squared. And what are we looking for?
Delta Y.
Delta y in this case, since we're going up and down.
Cool.
Doesn't
Alright.
really matter if we put y or x.
Doesn't really matter if you put y or x.
Thank you.
Okay, what is the equation that has all four of these variables?
Second one.
Second one, we get VFY, or VF squared equals VO squared plus 2G delta Y. So we sub our numbers in, so we get 0 equals 9.4 meters per second quantity squared plus 2 times negative 9.8 times delta Y, which is what we're looking for. Does not equal pi, Michael. What does delta Y equal?
4.51 meters.
It's in the ballpark of pi, I guess.
The 1 and the 4.
Pi is like every number. That's one thing.
Pi is every number ever, so I guess some these three digits
Every
are
number
included,
is.
included in pi somewhere. If we convert it to like
9.2652.
text, all your names are in pi. Also, with everything you ever said was in pi.
You can let it.
So if you convert your DNA like to a like number notation, all of your DNA is in pi. So is everything that
Pi's in my
pi is an infinitely long number,
Right.
and it doesn't repeat.
Right.
So every combination of numbers possible is in it.
Oh, I got
So if you convert something to numbers, it is in pi.
Wouldn't that
Yeah.
be true with any irrational number?
Any irrational number, non-repeating. Alright, any questions on number one here? Okay, can I erase that? Alright. Number two, a stone is dropped from a cliff. After it has fallen 30 meters, what is the stone's velocity? What's our initial velocity in this one?
0.
Stop playing with things.
It wasn't me this time.
What's delta y in this case?
Negative 30.
Negative 30. Why is it negative?
Because it's going down, 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 down.
So it ends up below where it started, so we gotta make delta y negative. What is g still? And what are we looking for in this problem?
Yes.
Yeah. What equation is all those?
We just
What we just used. Vf squared equals Vo squared plus 2g delta y. We get Vf squared equals 0 plus 2 times negative 9.8 times negative 30. What's our final velocity?
24.2 meters per second.
It's approximately 8 pi, Michael. Actually, it's gonna be less than 8 pi, but. Alright, what should go in front of this since we took a square root?
Plus or minus.
Plus or minus. There should be a plus or minus in front of that, so we gotta choose which it is. Is it going up or down? At the end of this problem, down. So our answer should be negative 24.2 meters per second. Everybody understand why it's negative? It's going down at the end, you gotta do plus or minus. Sean?
If like if we just have to like change the sign at the end anyway, do this like making the signs at the beginning different, does it really matter?
Like if you had positive here,
Yeah.
Yeah.
Like it would
you
make
get
a
the same
difference
answer.
anyway.
It would make a difference. You just been doing plus or minus. But in other problems it would. Does that make sense? Okay, Darius, this one. Alright, number 3. Car accelerates from rest at a rate of 1.8 meters per second squared for 10.2 seconds. Then continues at a constant velocity of 26.5 or for 26.5 seconds before it starts to decelerate at a rate of 3.2 meters per second squares until it comes to a stop. How far did the car go? This is the one you guys didn't like at the beginning of the year.
These are so, they're easy with it.
Okay,
Yeah.
how many parts are there to this problem?
3.
3.
Trace. Good job.
Alright, so we got part 1 is the car accelerating. Oh, I forgot, guys. There's an equation I didn't put on this. You should have v equals delta x over t on the top of the sheet, and that should be for constant velocity. So if the velocity is constant or there's no acceleration, you just use v equals delta x over t. So for part 2, where it says constant velocity, that's the equation you're going to use. Alright, so what's our acceleration for part 1? Not all at once.
1.8.
Thank you, Michael. What else do we know?
Time, 10.2 seconds.
Time is 10.2 seconds. What is our initial velocity?
0.
0. What are 2 things that we're going to find in this part that we're going to use for the other things? Remember, final velocity in part 1 becomes the velocity for part 2 and the initial velocity for part 3. So let's find final velocity. So we're going to use VF equals VO plus AT. VF equals 0 plus 1.8 meters per second squared times 10.2 seconds. It's our final velocity.
18.36.
Meters per second. What else are we going to have to find either, Michael?
You're gonna have to find distance.
Delta x, so
Yeah.
displacement, but usually the same as distance. So delta x, use delta x equals VOT plus 1/2 AT squared. And delta x equals 0 plus 1/2 times 1.8 meters per second squared times 10.2 seconds.
Squared.
Squared, thank you.
Mr. Kente.
Yes, Brian.
Can we use the delta x equals 1/2 final plus times time too?
You can use that. Why shouldn't you use that?
In case you're
Because your final velocity could be wrong.
Yeah. So if you use that equation, if you use an equation with final velocity, if you mess up here, you'll mess up there too.
Alright.
You'll probably get the same answer, but it's just a good idea not to like
risk it.
risk it. Yeah.
You gotta risk it to get the distance.
All right. What does delta x equal in this case? 93.64 meters for delta x. So that's the first thing we're going to add on. Now part 2 is constant velocity. So what equation are we going to use? Yep. So v equals delta x over t. What's our overall velocity for this part?
18.36.
Yep. It ended with 18.36 meters per second here. So its velocity over here is going to be 18.36 meters per second the whole time. So with 18.36 meters per second equals delta x is what we're looking for. What's our time for that?
26.5 seconds.
26.5 seconds. So what does delta x equal?
What? Wait, no.
486. 54 meters. Any questions on part 2 there? part 3, what is our initial velocity?
18.36 meters
18.36 meters per second. What's our acceleration?
per second.
Negative 3.2 because it's slowing down, so it's going to be negative 3.2 meters per second squared. What is our final velocity?
0.
0.
Okay.
And what are we trying to find? Part 3.
dx.
Delta x. If we were actually finding dx with respect to time, what would we actually be finding?
Derivative.
The derivative of position is
Acceleration.
acceleration.
Position.
Velocity. Derivative of position with respect to time is velocity. Anyway,
Use that day something, I can't tell what.
I'm tapping out now.
alright. So what equation has these 4 variables in it? So if it's 0 equals 18.36 meters per second, 1d squared, plus 2 times negative 3.2 meters per second squared, times delta x. And what does delta x equal? And what do we get when we add up our 3 delta x's?
634.4.
So that is our answer. Yes, that is a lot of pi.
A little over 200 pounds.
Alright. Questions about this one? Alright, can I erase this? Is this easier than it seemed at the beginning of the year?
Yeah.
Is it nice to know you've gotten smarter?
We learned this back when I actually semi-paid attention, so.
So you actually know this stuff, Michael?
Yeah,
When did you stop paying attention?
I don't
Day 2.
You weren't paying attention?
remember. Yeah, I don't remember. Did I made it halfway on my egg though? I just
Got
happened
this
to
phone 500,000 times.
You know that's gonna like deteriorate the screen of your phone, right, Michael?
So what if one day it cracks in half?
Get to the end.
You have one
Surprise, your screen cracks.
My phone did just hear that.
Alright, number 4. A rock is thrown downward from the top of a cliff with an initial speed of 12 meters per second. If the rock hits the ground after 2.7 seconds, what is the height of the cliff? Alright, what's the initial velocity of the rock?
12. Negative 12.
Negative 12. Why negative 12?
Down.
What's delta y?
Both meters. Negative 12. Or 12. We don't
No,
know
no,
delta
no.
y.
Sorry.
Oh, come on, man. T's 2.7. I misread the question.
T is 2.7 seconds. And G is negative 9.8 meters per second squared. In his defense, I usually ask you for the one that's we're looking for last. I forgot what we were looking for though after I heard the question.
Yeah.
Alright, what are equation?
Delta y equals beta 1 equals 1
Alright, so we end up with negative 12 meters per second times 2.7 seconds plus 1/2 times negative 9.8 times 2.7 seconds squared. And what does delta y equal?
68.12 meters.
We get a negative because we figured out how far it fell. If it's asking for how high the cliff is, we'd make it positive, but I'd accept either answer. Everybody understand that? Alright. Last one. Can I erase this? Alright, when someone throws a rubber ball vertically upward from the roof of a building, 9.59 meters in height, if the ball rises, then falls. It just misses the edge of the roof and strikes the ground. If the ball is in the air for 3.39 seconds, what was its initial velocity? I'll grab a new marker. Alright, so what is delta y in this case? Negative 9.59 meters. So we have to, that's negative because it ends up lower than where it started. Now remember, we do not have to incorporate the up part. That'll be done for us when we solve for it. As long as we keep our signs correct, we're going to get an upward initial velocity, so we're going to get a positive sign for that, and that'll take into account the up and the down part. Does that make sense? We don't need to break it down into steps. You can if you want, but you don't need to. What is our initial velocity? That's what we're looking for, isn't it?
Yeah.
Yeah.
We have time.
We have time is what, Michael?
3.39.
And we know g is equal to negative 9.8 meters per second squared. Okay. So we end up with delta y equals VOT plus 1/2 GT squared. We get negative 9.59 equals VO times 3.39 seconds, meters, plus 1/2 times negative 9.8 times 3.39 seconds quantity squared. And what's our answer? 13.8.
Is that what Chloe got? Hang on.
That is right, I checked it.
Is it? Oh, it is? Then
13.8 meters per second. Questions on how I got that? One thing, guys, make sure you're careful on, to remember, lots of you making this mistake before. Remember that 1/2 times 9.8 is 4.9. And if it's like this equation, VF equals VO squared plus 2 times 9.8 times delta y. What's 2 times 9.8?
19.6.
Not 4.9. So remember, I know you guys sometimes, a lot of times they'll do this part in your head, and this part in your head. This is negative 16.9. This is negative 4.9. 19.6. Thank you, Michael. So make sure when you're doing that in your group quiz tomorrow not to mix that up. Any questions on anything going forward here? Nope.
Going to that.
Alright, you guys have any random science questions you'd like to discuss?
On camera?
You can discuss a science question on camera.
I had one.
You cannot talk back. If you guys got nothing, we'll do something
let's
else.
discuss the ice.
Discuss
You
touchscreen
already
phones.
done your eyes. with-
Why doesn't any other material work
And when it's
other than a phone?
What?
Only my-
Touchscreen phones?
Yes, why does only
I
my phone?
believe in general with a touchscreen phone, it's also the same with like your mouse pad, is they are heat sensitive. Have you ever noticed they don't work when you like after you wash your hands?
What
This-
is that just the iPhone or all? Because mine used to, like, I can use like a pencil and that.
There are, like, it depends what it is. So some of them are pressure sensitive. You can make a pressure sensitive one. Some of them are heat sensitive. So if like nothing else works other than your finger, it's probably heat sensitive, and especially if like after you wash your hands, like your hands are kind of cold, if it doesn't work as well then then it's definitely heat sensitive. If like you can use anything that's pressure sensitive, there are also like my computer has a special pen you can use as well as your finger. So I think this screen is heat sensitive, but I'm not sure. I haven't really done anything to look at it. Mouse pads, like on laptops, are usually heat sensitive as well. If you have cold hands, they won't work as well. So a lot of times if my mouse pad's not working, like in the winter, my hands are cold, I'll like breathe on my fingers and it'll work. Gabe?
Isn't it just from electrical conduction? Because you have like a little bit of electricity in your fingers, don't you? Or like in your body.
You do have a little bit of electricity in your fingers. I believe, like I said, those are usually pressure sensitive because they don't want like things being conducted from your hand into the laptop. So it usually has like a heat, like, I'm trying to think of have you ever seen like a pad that has like, you put your hand in and it warms up? It essentially is something like that detects the heat temperature. And you can always tell like how it works is if you take like your like a cold, if your hand is cold and it doesn't work, then it's definitely heat sensitive. Does that make sense? Okay. Any other random science questions?
Do you play euchre?
I do play euchre.
Okay, so you have the left bar, is that the higher one? The right?
Right.
No, the right's the higher
Right,
one.
right is
Okay.
the higher one.
So you have the right bar. Do you play the second trick or the third
Oh
trick?
my gosh.
No, I want to know. I think you should play it the third one, right?
depends.
You should play. Okay, if you have another, if you have
It
another
depends
song,
what you have in your hand.
then
There is an ideal way to play.
is there?
If you have, let's say you have the right and low cards low trump other than that. So if you have the lead and you have the right and low trump other than that, you want to lead it first because it will, like if you lay like the queen and somebody has the king, then you lose. But if you lay the right, somebody just has the king,
Great.
then you win.
But what about if you're looking to draw out the left? Wouldn't you want to wait then and see? Because what if they have a protector? Wouldn't you want to try to draw out the protector first before using it?
It should
Or
be.
you're gonna lose a trick
It
either way,
depends.
so
A lot of times, a lot of times it's going to be inconsequential. If you lose to the left, if they have a protector, unless they play badly, you're going to not get that trick.
Right, get that trick. Okay, that makes sense.
Anyway, that was not science, but close enough.
Well, you can talk about poker ones.
We didn't talk about poker ones. That was statistics, though. Any other random science questions?
I think they just, like I know all
Get ready,
the
Elena.
stuff, I just.
I gotta
I'm
go.
so excited.
All right.
Honestly, I wanna know
Let's
what.
play you, let's play
Prepare.
you.
No, we're not playing it right now.
Playing cards,
All right.
Can we play with the buzzers?
Have you ever
Hey,
played
let's play a
Blogus?
game.
We can do some review with the buzzers if you want.
Have you ever played
Hey, here, let's play a
Blogus?
game.
I've never played Blokus. Is that the?
You would like it.
I think I've played that. My nephews have it.
Except there's
Anyway, I'm gonna turn off the camera now.
I played a lot.
there's many strategies you can do Blogus.
Not kidding.
Except
Have a good day.